Okay, let's go into number 3. Let's do 4. No, which one's going to take a long time? We're going to skip 2. We just did 2. I don't know if I'm going to have time to make a video for number 2. I'll steal from somebody else. 3 you need practice on. Not many of you did well on that question on the mock exam that we took, so let's do it. At both position 1 and position 3, the distance between A and B is 5 feet. Okay. So we go from a distance of 5 feet to a distance of 6 feet, back to a distance of 5 feet. No, from the dash center line. Wait. Okay. Distance between A and B is 5 feet. But position 2 is when they're 6 feet, each 6 feet from the center line, which means they're 12 feet apart. Okay. Okay, t equals 0. T equals 3. Is the paddle reaching position 3 from the first time, back to 5 feet away from each other. Okay. So the period is 6 seconds. Let's remember really quickly, period is like the time per cycle. If it's cycle per time, that's frequency. We want time per cycle. Cycles per second, frequency. Okay, so 5 points F, G, J, K, and P are labeled. Models the distance between A and B. But F would be T equals 1.5. We could say this is T equals 0 here, when the distance is 5 feet. The distance is a max of 12. T1. I don't know if we did a good job explaining which points are which here. Because we're starting with a minimum distance, not a maximum distance. All right, well, it's up to us then. We could call this this is kind of like, why didn't we start with the max and then go to the min? The minimum distance is 0 or 3. So this is T equals 0, sure. This will be T equals 3. Let's take the period. Period is 3. Divide that by 2 pi. Period is 2 pi over B. Or B equals 2 pi over the period. period is 3, b is 2 pi over 3. Okay. The period being 3 cut into fourths means each important point is 0.75 seconds away from each other. This is how we get the 1.5. This will be negative 0.75. This will be negative 1.5. I mean, I don't know if they like these negative times, but it's possible coordinates. So part A, if this is a distance of whatever it is, you can divide it by 2. We don't have our calculator to do this. You find the average between them to find the midline, or you can find the amplitude and then subtract. So 12 plus 5 is 17. 17 halves is 6.5, 8.5, 5, 6, 7, 8.5, 3.5, 8, 9, 10, 11 and a half, 12. Okay, so that's 8.5. So yeah, how did I find 8.5? There's lots of different ways. You could do 12 minus 5, which is 7. That's the total distance from 12 to 5. Divide that by 2 to get the amplitude. There's my amplitude. Anyways, let's just write down the points. Negative 1.5 comma 12. Negative 0.75, not 7.5. 8.5. 0, 5. 0.75. 8.5. 1.5. 12. All right. Find the constants A, B, C, and D. We have a sine function, so it's up to you what you want to do. Why don't we just say K is our starting point? That way we have a positive sinusoidal function. So I took the regular sine function. I'm going to shift it to the right 0.75. So I need a minus 0.75 here. I know the period is 3/4. So 2 pi, the period is 3. 2 pi over 3 gives me B. I've shifted my midline up, and I have an amplitude of 3.5. So A is 3.5, B is 2 pi over 3, C is negative 0.75, D is 8.5. There are other variations of that. You could start at G and do plus 0.75. Let's just make sure we have our normal sine graph that starts at 0, 0. I will go up 8.5, go to the right 0.75, and now I have this point K. A lot of people think they have to shift this point left, so they have a plus, but that would be going like in the opposite direction. It's like, think about starting with your parent function, getting to K. So I want to shift my parent function up 8.5, right 0.75. Okay. H. Now, let's remember, if H is positive, if our graph is positive, we are talking about our graph being above the x-axis. Between T1 and T2, which is G to J, we are positive. We are above the x-axis. We don't have any negative values. What is it doing between G and J? It's positive and going down. So B is the answer. But what about the rate of change? The rate of change is increasing. Why? Because it's decreasing concave up. H is concave up. They don't ask you for why. Therefore, the rates of change are increasing. Cool. That's tricky. That's tricky, like especially with the points. I think he's just like whoever made these problems, Mr. Passwater, made these points to be the same every single time, which is forcing us to change things. I think on the actual AP test, they don't necessarily always give you the points like this. So let's just figure it out. Camel spin, great. Okay. 6 cycles, 6 rotations per second. The period would be therefore 1/6 of a 1/6 of a second per one rotation or one cycle. We got to flip. This is a frequency, and a cycles per second. Period is how long it takes to get one cycle done. We think of 2 pi being like the x length, like a time it takes for my graph. So that's very important. Period is 1/6. The wall, the center. All right, point B is 3 feet away from the center of rotation. So we are talking about point B being 18 feet from the wall, 15 feet from the wall, or 21 feet from the wall. That's a good place to start as a spin. At time t equals 0, B is the furthest distance from the wall. So at least this lines up nicely. The first question did not line up nicely, but made for a nice challenging question. A sixth of a second per rotation means this is 1/6. If the period is 1/6, multiply that by 4, you get 1/24 is your step. This will be 1/24 of a second. This will be 2/24. Please simplify. This will be 3/24. Please simplify. 1/24, 1/12, 1/8, 1/6. All right, now we got points. F is 0.21. G is 1/24, 18. J is 1/12, 15. K is 1/8, 18. P is 1/6, 21. Write the function in a sine. We were going to do sine. All right, let's start with G. My amplitude is 3. My period being 1/6. Period equals 2 pi over B. B equals 2 pi over P. So if my period is 1/6, I'm going to have 12 pi. I'm going to make a negative so that we flip things and we go down first. C, take our parent function, shift it to the right 1/24. C is going to be minus 1/24. Careful. Make sure you're paying attention to whether it's plus C or minus C. Since it's plus C, I need a minus 1/24 to shift my parent function to the right 1/24. And then D is 18. So one version of my expression for H of T is -3 sine 12 pi T minus 1/24 plus 18. G and J. We are positive because we are above the x-axis. We are decreasing. This is the same thing. Positive and decreasing, and the rates of change are increasing. Why? Because we are concave down. Concave up. Increasing because H is concave up. Just say increasing. The rates of change are increasing. Don't say increasing concave up. Don't say that. Don't say that. You say it's increasing because H is concave up. But they don't ask you to justify. So we are decreasing at an increasing rate. All right, Wheel of Fortune. Okay, 8 feet in diameter, point S. Are we talking about one rotation every 8 seconds? Okay, that's a period. 8 seconds per one rotation. That's important. Make sure we understand whether we have a frequency or a period. They're telling us the period. Time per one cycle. The height of S. The height S above the pointed indicator. Oh, here's the pointed indicator, the height S. Okay. This is where we're going to deal with some negative values, and that's great. It's tough to kind of create because it's like above. So like S is going to be 4 as a max. S is going to be -4 as their height above this pointed indicator. So that's good. S is at the same height as the pointed indicator. 8 seconds per cycle, so each step will be 2 seconds. So this is 2, this is 4, this is 6. Back to where we start, this will be -2. We're good. I like the last question with the fractions. Okay. It's the model. Do we get a cosine in here? We got to change it to cosine sometimes. It's not sine every time. There it is. All right, so we'll get to cosine. I'll do both, actually. Why don't we remember how to do both? Could have done both for the previous ones, too. If I did cosine, I would do -3.5 cosine 2 pi over 3 t minus 0 plus 8.5. Because I'm going to start at that point j. If I did cosine, I would probably start at f, and it would be +3 cosine 12 pi t minus 0 plus 18. Yeah, I should just do both. So b is 2 pi over the period is 2 pi over b is 2 pi over 6. So the value I need is pi over 3, so that when I plug in 6, I get 2 pi. This is me doing my horizontal dilation. My amplitude of 4. If we're starting at G, then let's go and make sure A is negative so that we go down first. I got sine pi over 3 t minus 0 plus 0. That's perfect. All right, sweet. Now, H is below the y-axis. H is negative. If H is negative, we're not talking about H's rates of change. It's like the values of H being negative means the graph is below the y-axis, x-axis. Why do I keep saying that? Below y equals 0. So H is negative here. But between J and K, H is negative and increasing. H is concave up, so the rates are increasing again. Rate of H is concave up. Just circle that answer. They don't ask you to explain why. It doesn't even say describe the characteristics of the rates of change. It just says how are the rates of change changing? That's it. It's just referring to the second derivative. The rates of change are positive and increasing. The rates of change are negative and increasing. I don't think they want that. Negative or positive. Just how are they changing? Oh, I'm gonna check on that. So I conferred with my colleagues. We're not exactly sure. I think it's just increasing. But I guess to be safe, between J and K, you could say the rates are positive and increasing. Here, H between G and J, the rates are negative and increasing. This might be safer. Like maybe they want both of those characteristics. But usually if I ask you how are the rates of change changing, you just say the rates of change are increasing or decreasing. Here, between G and J, yeah, the rates are negative because the function is decreasing and increasing. That's probably safer putting both of those in. So like, let's just go to the next question, go straight to T1 to T2, which is G to J. I mean, let's just change it up to F to G. You don't need to know about the Y values. From F to G, the rates are negative and decreasing. We are decreasing concave down. We are decreasing at a decreasing rate. The rates of change are negative and decreasing. The rates are negative and decreasing because H is decreasing. Negative rates decreasing. And concave down. All right. Let's just finish off this question. Price is Right. 2 rotations every second. That's fast. Okay. That's a frequency. Frequency. 2 cycles per 1 second. The period is a half of a second per one cycle. You could say 1 second per 2 cycles, a half of a second per 1 cycle. That is important. Okay. Height above the level ground. 5 feet above ground. 8 feet total. Oh, this is a little weird where it's like, this is not 0 at the minimum. We're going to go down 4 and up 4. So that means the base of the wheel is 1 foot off the ground. So we like shift everything up 1. S is at the same height as the pointed indicator. All right. We have a half of a second per cycle. So all the way over here is a half a second. The step is going to be 1/8 of a second. So this is 1/8. This is 2/8. Simplify. This is 3/8. Thankfully, can't simplify. That's 4/8. That makes sense. This is negative 1/8. We got our points. Hey, we got cosine. All right, well, A is 4. We'll start at point F, which means I need to take my parent function, shift it left. So plus 1/8 shifts my parent function left. I have that period, which is a half. B equals 2 pi over the period. So that's going to be 4 pi. And then my midline is shifted up 5. So there's A, B, C. Make sure you're paying attention to plus C or minus C. Make sure you're paying attention to sine or cosine. And D. All right, between F and G, we are positive. We are above the x-axis. We are decreasing. Between F and G, the rates are negative and decreasing. It's going to be safe if you put both the sign of the rate and the how that's changing. I think that's safe. You're not going to lose a point. What you will lose a point on is trying to be too cute with it. If you say the rates are negative, decreasing because concave down, and like you don't specify the rates are negative because H is decreasing. The rates are decreasing because H is concave down. Honestly, leave this statement off and you're safe. All right. That's question 3. Let's jump into question 4.